The mysteries of our solar system have long fascinated scientists, but something strange is happening in the dark zone beyond Neptune. Imagine discovering a new planet in the shadow, a massive body about 10 times the size of Earth. If true, it would be a scientific miracle, a discovery that could redefine our understanding of the solar system. This mysterious entity, tentatively named Planet 9, has yet to be directly observed. However, there are compelling indications that another massive object exists in the darkness of the Kuiper Belt. Scientists' belief that there must be something there stems from significant anomalies observed in the orbits of a group of trans-Neptunian objects, TNO. As of 2016, 6 such objects have been identified, including Sedna and Alicante, which have been well studied. 4 more objects were left from close observation. These TNOs, sometimes called SIDS, show visibly clustered orbits, suggesting that they are affected by the gravitational pull of a very large but invisible object. The hunt for Planet 9 began in 2012. It should be noted that the 3 main planets, Pluto, Neptune, and Uranus, were discovered only because of observed orbital anomalies. This search was aided by the pioneering efforts of the American astronomer Michael E. Brown, who intensively studied the Kuiper Belt. Brown, who in 2006 discovered Erik, a dwarf planet so similar to Pluto that it lost its planet status, was relentless in his search for the elusive planet. In 2012, another scientist, Rodney Gomez, proposed the existence of another large planet in the Kuiper Belt. At first, he proposed a planet about the size of Mars or slightly larger, comparable to Neptune. Mike Brown analyzed the orbit of 2012 VP-113 with Chad Trujillo and Scott S. Shepard. Their findings indicated that Planet 9 must be much larger than previously thought. In 2014, they claimed a larger-than-Earth planet that takes 7,000 to 10,000 years to orbit the Sun. French scientists evaluate data from the Cassini spacecraft and also expressed their belief in the existence of a planet. Cassini, which studied Saturn's surroundings until 2017, provided valuable insights. Some scientists even hoped to direct the probe to the Kuiper Belt, but NASA decided to end the mission after its main goals for Saturn were achieved. Despite a few quiet years in this field of research, Mike Brown never gave up. In collaboration with Konstantin Batygin, he continued to observe objects in the Kuiper Belt and created new mathematical models and computer simulations. In 2024, the duo presented a new clue. Their simulations clearly showed how the orbits of TNOs lined up with a planet about 10 times more massive than Earth. The probability that these strange constellations in the orbits of TNO are coincidental has been calculated to be only 0.007%. The idea of an ice planet larger than Neptune sounds amazing. Imagine a massive planet suddenly appearing in our telescopes. That would be monumental. Brown and Batygin estimate the mass of Planet 9 to be 10 times that of Earth, revising old calculations that suggested it could be greater than Neptune. New calculations show that Planet 9 is about the same size as Neptune and may have a similar structure. This would make Planet 9 one of the largest planets in our solar system, but how could we pass such a large planet so far? The answer lies in its orbit. Planet 9 orbits so far from the inner regions of the solar system that it remains almost completely dark. It probably only approaches the Sun in a highly elliptical orbit every 6,000 to 7,000 years. The rest of the time it moves farther and farther away, making it incredibly difficult to spot. The area where the planet could be located is huge. Astronomers once thought there was little beyond Neptune, but now we know there is still a huge belt millions of kilometers long that we know very little about. Exploration of the Kuiper Belt and TNOs has only just begun. Who knows what else could be hidden in this vast area? What if Mike Brown is wrong? For almost 12 years, scientists have debated whether this planet really exists. While Brown is confident, other scientists are working tirelessly to prove otherwise. They suggest that the orbital deviations of TNOs can be explained by the mass of the Kuiper Belt or other unknown phenomena. One of the more extraordinary theories requires the existence of a small black hole with such an enormous mass and gravity that it unites the orbits of TNOs. Brownian statistics show that these models are unlikely, with over 90% probability that Planet 9 exists. However, there is a chance that Brown is wrong. Historical examples such as the search for the hypothetical planets Vulcan, Trans-Pluto, and Tyche show that scientists can be wrong. Vulcan was thought to be a planet between Mercury and Venus, which explains some of the anomalies in Mercury's orbit, but it was never found. Trans-Pluto, a proposed Neptune impact object, was another idea that did not materialize, despite claims from semi-scientific sources. If the existence of Planet 9 is confirmed, it could change our understanding of planetary definitions and possibly restore Pluto's status as a planet. Mike Brown, known among experts as the Pluto Killer for his role in reclassifying Pluto, would see his legacy further cemented. The International Astronomical Union, IAU, would be responsible for naming the planet. Being one of the largest in the system, it would probably have been named after a Roman deity. Possible names include Janus, god of beginnings and transitions, Somnus, god of sleep, Fortuna, goddess of luck and fortune, or Nox, goddess of the night. The probability of finding Planet 9 in the next 5 years will increase with the development of new telescopes. The Vera C. Rubin Observatory in Chile, which is set to image the entire sky for a decade, is particularly good at detecting faint and distant objects. The James Webb Space Telescope will soon be joined by the Nancy Grace Space Telescope in Rome, which could also play a key role in searches with high-resolution instruments. In addition, Chile's ALMA Observatory is being upgraded to improve its ability to observe cold objects in the outer solar system. Discussions are already underway to send a probe to Planet 9, although its existence has not yet been confirmed. Missions to regions beyond Neptune can take a decade or more to reach their destination, depending on planetary alignment. Scientists agree that a probe is urgently needed to explore the outer reaches of the solar system. Currently, New Horizons is the only probe moving in this region. New Horizons was originally launched to study Pluto, its moon Charon, and some Kuiper Belt objects. New Horizons is now 8.88 billion kilometers away in the Kuiper Belt. Considering the extent of the area, it would be lucky if the probe happened to see traces of Planet 9, making the name Fortuna quite appropriate. As the scientific community awaits the release of these advanced telescopes, tension and excitement are building. The Vera C. Rubin Observatory makes up for its wide field of view and ability to detect faint objects. Meanwhile, the Nancy Grace Space Telescope in Rome may provide the final proof needed to confirm the existence of Planet 9 with its high-resolution imaging. The advanced ALMA Observatory, with precision antennas tuned to millimeter and sub-millimeter wavelengths, will further improve our ability to study cold objects at the edge of the solar system. The anticipation is palpable. Imagine when a new planet 10 times the mass of Earth appears in our telescopes. The discovery would not only confirm decades of research, but also open new chapters in our understanding of the solar system. This would be a monumental achievement, cementing the legacy of researchers like Mike Brown and Konstantin Batygin. Confirmation of Planet 9 would require a re-evaluation of our planet definitions, possibly leading to the restoration of Pluto as a planet. Naming this new giant, perhaps after a Roman god, would be a major milestone in astronomy. Excitement continues to grow as the potential discovery of a new planet approaches. The scientific community is full of excitement and the world is watching with anticipation. Will the Vera C. Rubin Observatory capture the elusive Planet 9? Does Nancy Grace's Rome Space Telescope provide hard evidence? Or will the ALMA Observatory reveal new clues? The coming years promise to be exciting as we continue our quest to unravel the greatest mysteries of the cosmos. Stay tuned as we embark on this incredible journey, pushing the boundaries of our knowledge and exploring the farthest reaches of our solar system. Finding Planet 9 would not only demonstrate human curiosity and determination, but also serve as a reminder of how much we still have to learn about the habitable universe. The tension is real, the stakes are high, and the tension is palpable. The hunt for Planet 9 continues, and with it comes new discoveries and a deeper understanding of our place in the cosmos.